Good morning, everyone. It's quite exciting to finally be here. I know that we've all gone through a lot to get here, and there's a certain amount of uncertainty, but we made it. It's not every day that just going to a conference is like a heroic deed, but we're almost there. It's based on the kind of environment we're in now. So I appreciate you making it out to this. It is exciting. I've been, I guess this is my third in-person conference since the pandemic started. Things are starting to open up a little bit. We shall see. But again, it's great to be back in New York. I don't know how many of you have been at a Postgres conference in this hotel before. I was. Anybody else? No, I didn't think so. Yeah, it was probably 7, 8 years ago. So it is really cool to be back. My name is Bruce Momjian. I do work for Enterprise DB, and I am one of the Postgres core team members. And Mark Linster was kind enough to mention my talk actually in his keynote this morning because he learned some things about how the open source lifecycle works and how basically open source evolves differently than proprietary software, and that's what I'm going to be talking about today. It is a really interesting talk, very positive, because there are some really cool things about open source. If you're curious about the darker side, I actually have another talk on my website, which is listed right down here, called Future Postgres Challenges. So although this is a wonderful, everything's great talk, there are continually potential problems, potential things we have to, navigate and avoid. And fortunately, we've had a very long history of success as a project. But that doesn't happen as an accident. We're always looking to make sure that the project is positioned well and that we are considered to be leaders in the industry and so forth. So if you're interested in that other talk, Future Postgres Challenges, again, check it out on my website. Also, these slides are on my website. There's another 55 other presentations on my website, 90-some videos, and over 600 blog entries. So if you're curious about it, check it out. But today we're going to talk about what is a really interesting topic, something I never would have thought of, but somebody recommended it to me, and I was like, wow, that's a really interesting topic. Will Postgres live forever, right? Kind of a really weird for me, it was something I never would have thought of. But as I started to think of it, I realized that there is actually some really interesting material here. First, we're going to talk about forever, and particularly the life cycle of software versus the life cycle of civilization, the life cycle of the universe. It's kind of mind-blowing. We're going to talk then about, and I think this is the most important section, about the life cycle of software. And it's something most people don't think about, but having been in the industry for 35 years, I've seen life cycle of software come and go, and why does it come and go? We're going to talk about that. And how is open source unique in that area? We'll talk about that. Then there's a survey in section 3 we'll talk about. It has to do with open source adoption. I think you'll get some really interesting ideas out of that. And then we move into sort of the Postgres section. We'll talk about innovation of Postgres and the community structure, and then finish out. So let's start talking about forever. Forever is a long time, and I really have trouble understanding what that is. For example, the age of the universe computed to be something like 13 billion years. That's really hard to imagine for any of us. Age of the Earth, similar. Age of civilization, 6,000 years, obviously very small compared to the age of the universe Earth. The civilized era versus the age of the Earth, again, you're talking a tiny percentage. And the digital era, it might as well be zero, right? I mean, it's so small that, and the weird part is we've all grown up in this digital era. Even people, obviously, the internet came, we got on the internet, I think, in 1990, 1991. I had to explain to people what email was, right? What a website was, what Usenet was. So there are people now, obviously, growing up who are, they know the internet from when they're 6, right? We have somebody living with us currently who's 6 years old, and she knows what the internet is. I certainly didn't know. We didn't have it when I was 6 years old. We didn't have it when I was 16 years old, right? We barely had it when I was 26 years old. So again, the era that we're talking about is very small, and there's some patterns that I don't think we've really internalized yet. There's some things about the digital era we're living in that we're just kind of figuring out. Because again, civilization 6,000 years, the digital era is very small compared to that. And what I'm going to basically do is open up some of that and talk about what conclusions can we come to? Where is open source going in all of this? Why do some software projects stop? Why does some software go obsolete, right? And what does that mean for us as engineers, because we need to predict what the future is going to be. And we can't do that if we don't know what the past was, right? Looking at the history of digital, the digital history, the Jacquard loom is probably one of the early mechanical examples of basically a digital programming. In that case, it was a loom that would make rugs, I believe, or fabric. And they had a program that you could program what threads got in to make whatever patterns, right? Again, way before computers. I'm from Philadelphia, the ENIAC, the first sort of commercial computer out of Philadelphia in 1945, not that long ago, again, considering the age of everything else. 1970, E.F. Codd began relational theory. 50 years later, we're still using relational theory, right? Who would have guessed? I remember in the 90s and 2000s, there was going to be, first it was like XML databases were going to win, and then object databases were going to win, and then NoSQL was going to win, and they were going to wipe out relational. And 50 years later, we're still here. So there's something fundamental about, I think, relational technology that I have covered in some of my other talks. But again, interesting that some technology lasts a long time and some technology doesn't. System R from IBM, 1974, first relational implementation. 1977, Ingress, same university that produced Postgres, University of California at Berkeley. 1986, Michael Stonebreaker starts the work on Postgres. Really was just a research project funded by DARPA. Probably didn't expect it to go anywhere. By the time I started in 1996, it was almost an abandoned project. So myself and Mark Fournier kind of looked at this software, saw potential, and said, this could be something interesting and something useful to a lot of people, but it needs organization. It needs, a communication method. It needs some sort of patch management and release control. So that's really how it started. It started 10 years earlier at Berkeley, but by the time it came to us, it was kind of on its last legs. And fortunately for us, 25 years later, we're still working on it. Who would have guessed, right? It's surprising to me, as it probably is to everyone else. So just to give you a life sort of ridiculousness, this is the computer we had at high school when I was in high school. Okay, this is a Wang 2200, I believe. We had one of them for the whole school, okay? It was in BASIC. So my point of this slide is twofold. One, obviously things change a lot. I'm 59, I'll be 60 on Sunday, but to start at this level is pretty bad, embarrassing now, looking at it. But secondly, nobody's using this anymore. This, I believe, is a picture. I don't know where this picture's from, but I saw one of these at the San Jose Computer History Museum. So when you see your own computers in a history museum, you're old, right? Pretty much. But the point is that hardware does not last, right? Hardware wears out. It's a mechanical thing. Typically, heat kills it, or electric spikes, or whatever. So hardware doesn't last. I assume nobody's using this in production anymore. Software, on the other hand, is different, right? So as I said before, Postgres still being used, 35 years later from its origin, still being used. Why? Because it's not a physical thing. It is a concept. It's a set of instructions. It's something that can evolve, right? It doesn't wear out in the same way as hardware does. So when we're talking about will Postgres live forever, we're talking about something that effectively is not tangible, but in fact is an instantiation of somebody's ideas. And those ideas can be changed, those ideas can be improved, those ideas can be modernized without having to rip apart some piece of hardware, right? So that's primarily, and if you're curious what those two little white things are, I think one was brightness and one was contrast. So I know somebody is thinking what those two white things are on the right, and I believe that's what it was. So this is the most depressing slide of the whole deck. Why is it depressing? It's because I think of all the software that I used that was really cool when I was a kid that is not here anymore. And I know we can all think of some computer games or some really cool utilities we used, and they're just nobody uses them anymore. They don't exist. Nobody. Why? Why? If I just explain to you that hardware wears out and software doesn't, why is a lot of software that we used years ago not around anymore? Well, it could be a bunch of reasons. Maybe it doesn't fill a need anymore. Maybe the language it's used isn't relevant anymore. But there's a more fundamental issue here, and I want to go through this because as we start to talk about this proprietary life cycle, we're going to start to look at how the open source life cycle is different, and then we're going to start to think about how the database industry has changed over the period. Because again, as I said before, one of the goals of this talk is if we're engineers and we're supposed to be able to predict the future, we have to look at patterns of what we've seen in the past to try and understand the future. A lot of people think today is just today, and therefore it's going to be just like yesterday, and tomorrow's just going to be like yesterday. But there are these very slow-moving changes that happen in the industry that a lot of us miss. I know I missed it until I started to really think about it. And the goal here is to kind of walk through that. So let's talk about the proprietary life cycle. And again, this is one of the reasons that a lot of software that you used maybe years ago, you don't use anymore, okay? And that's because the proprietary software lifecycle is very structured. I'll talk about open source in a minute, but let's talk about proprietary. It typically starts at stage one, which is innovation. It's somebody who's creating something new, something that doesn't exist in the market yet, okay? They're going to hire some engineers. They're going to put those engineers in an office. They're going to have meetings. They're going to have the engineers work on the software until they can get to a version that they can release to the community. And this might take a year, it might take 2 years, it might take 6 months. It's going to take some amount of time where you just have to invest in engineers producing software that's never going to be used yet, and not going to be used right now. Okay? Then you enter, once you get to something you can release, you enter stage two. And stage two is what we call market growth. In market growth, we have something to sell, and we have to figure out how are we going to grow our market with our new product. You hire salespeople, you bring in marketing people, you run advertisements, you do giveaways, you set up a website, who knows what you do, okay? But in stage two, your primary focus is to get customers, all right? But then at a certain point, you enter stage three, what we call market saturation. You've either got all the customers you're ever going to get, or there's another maybe competitor who you're really not able to supplant, and maybe you're stuck at 25% market share or 75% market share, or whatever percentage you're basically at, okay? And at that point, you're really not growing anymore. You're just kind of stagnant. You're just kind of flatline. You know, we got customers. We're producing the software. They're continuing to buy it at a steady rate, okay? But then you enter stage four. And this is the stage I call profit maximization. And in profit maximization, the organization has really realized almost no matter what we do, we're not really going to get more customers. So what do we do? Okay. Well, we got the customers. They're paying for the software. They're probably going to continue to pay for the software. So we're just going to maximize profit. We spent a lot of money in the beginning to create the software, right? And we sold it for a while, but now we're kind of just maximizing profits. And at the same time, we're going to minimize costs because effectively profit is, revenue minus costs. So if I can't grow my revenue, how do I maximize my profits? I reduce cost. I reduce development, I reduce support. My company starts to look old. My company starts to look non-responsive to customers anymore, okay? And I'm basically just kind of coasting along. And this is a really bad state to be in because you're effectively getting smaller and smaller and smaller. You're not bringing in new customers. Your customers are probably not happy. There's no innovation going on probably at this point. And then you basically enter stage 5, which is maintenance mode. And a lot of software is in maintenance mode. It has no new features. It has no innovation. The only thing the company's going to do is support existing bugs and maybe upgrade it for new operating systems or new platforms. Okay? And then finally, you reach the end of life. And the end of life happens when they can't make money off the software anymore. And this is where all the software goes to die. Right? The market segment is now so small because they've effectively maximized profit. They haven't innovated anymore. They're basically cutting support. They're cutting development. And now you've just reached this end of life stage. And as soon as they can't make money on it anymore, the software is dead. It's gone. All right? I told you it was a depressing slide. I'm thinking of some software that I really wish was still around. That's the depressing slide. If I look at open source, it's really a different ballgame, okay? The first thing you start is probably parity with open source or some kind of low cost alternative, or it may be something like Kubernetes, something completely new in the industry, right, that didn't even exist, right? And then the project will shoot for market growth because they want people to use their software. They'll set up a fancy website. They'll speak at conferences, trying to basically get people interested in what they're doing. But there's no real final stage. They go in stage 3. They either continue to innovate or decline. Really 2 choices. But they don't have a profit to maximize because they don't have a profit. There is no cost reduction because there's no cost, right? I mean, this is traditionally where Postgres is, where Linux is, all these sort of open source projects who don't really have a profit margin or a profit motive, so there's nothing to cut, there's no cost. You either attract more people or you don't attract more people. You either get new features from new people or you don't get new features, but there's no sort of end. Because at stage 4, the software is always available to continue, right? Because in the previous option, when it became end of life, only the people who controlled the software could release it. And as soon as they couldn't make money, they stopped releasing it. But in open source, the code's always available. So even if somebody stops working on it, somebody else can come along and continue working on it. Now, you might think that's a very unusual thing to happen. It doesn't happen very often. Well, it certainly happened for Postgres because, as I said, when in 1996 when I started, it was kind of abandoned. There was one person, Jolie Chen, working on it. He was putting out releases every couple months, but there wasn't the kind of vibrant community that would have allowed it to continue. But because it was open source, because it was BSD licensed, we could continue working on it and develop a team around it. Some of the people who were on that team in 96 are here at this conference. Oleg and Jan, I think, were both heavily involved at that point. I hope I'm not missing anybody else. But it's the concept of having that software always available actually means something. This is the craziest open source story I've ever heard. And I just want to kind of give you an outline of what this is. And I only know about it because my oldest son loved playing a game called Falcon 4, which was released in 1984, started developing in 1984. I think the first release was maybe 89. And they released all the way through the 90s. I'm not sure I remember what year he was really involved. I think it was in the mid to late 90s that he was involved with this game. And in 1998, they released their final version, which is Falcon 4. Okay? Spectrum Holobyte was the company. They owned the software. It was proprietary, so they kind of controlled it. And then 1999, they decided we're not going to develop it anymore. There wasn't a market for it. They didn't feel they could really innovate anymore, and just kind of stopped on it. But then a weird thing happened. In 2000, somebody leaked the software to the internet. I don't know who it was. It was only leaked for maybe a couple weeks. But it was leaked long enough so some people grabbed it. And they created a group called Benchmark Sims, which effectively took this leaked software and laid it over top of the installed software. So even though they had control of all the software, they knew legally they weren't allowed to sell or use that software, so they could only enhance somebody who already owned the game. So in 2003, they released something called Benchmark Sims, which is community modifications on top of this proprietary game. 2005, a company called League Pursuit takes the open source mods and includes it in a new game. So it goes back to closed source as something called Allied Force. Then in 2015, 10 years later, people are still playing this game and they can't find the CDs anymore. So GOG.com, as well as released actually the CDs you could buy for Falcon 4 for the game from 1998. It's been on Steam since 2016, so it's another way to get it. And then in 2021, even in October of this year, 2 months ago, BMS released a new version of this game. So it's gone from closed to open to closed to open to closed again. I don't even know where it is now. In fact, the current version cannot be sold as a product. There's a license requirement, so it's not like open in the same way. So I don't even know how to explain it. But my point is, and this is illustrative, that because of the leak of the software, this game is still around 20 plus years after its end of development. Just to illustrate exactly why this happens, this is the typical flow for proprietary software. All the development happens on the left, and on the right are the users. So there's very little interaction between the two, and the group on the left really controls everything that's going on. In open source software, it's all together. You're going back and forth, whether it's testing, features, releasing, bugs, all this is happening in a unified way. And that's one of the reasons that open source is so vibrant and so popular today. When we started with Postgres, it was clearly less feature-filled, less performant, less reliable than closed source solutions. But because the adoption curve of Postgres was steeper, no matter how low you start, if your adoption curve is steeper, you're eventually going to cross and surpass. And that's a fact. That's actually what happened with Postgres. I mean, I think we're probably somewhere up. I'll use my pointer here, right? And we're probably somewhere up here now in terms of where we are compared to proprietary databases. We didn't start there. But the point is, because of that open source development process, we were able to improve features, performance, and reliability faster than proprietary systems, because this is so much more efficient than that. I mean, the classic question, how do you make a free project with no money better than billion-dollar companies like Oracle and IBM and Microsoft? And the answer is, it's because this is so efficient, and this is so inefficient, and this is so efficient. Okay. You might think I'm just making this up. It's just I just had some bad alcohol this morning. But in fact, I've lived through this with Linux. When I started in the industry in the 90s, most of our customers were using proprietary operating systems. HPUX was the one I used a lot. AIX was huge. Solaris was even huger, right? But what happened is that Linux and FreeBSD and others effectively using that process that I explained, were able to improve their features, their reliability, and their performance, and they were able to surpass operating systems produced by billion-dollar companies. And that started really in the late 90s, early 2000s, and now who's deploying brand new on any of these operating systems, right? I mean, you don't say, hey, I'm going to have a startup and I'm going to standardize on Solaris, right? I mean, that would have made sense in the 90s. Everyone did it, but now you'd think something's wrong with you, right? I mean, in fact, Solaris is end of life. Solaris is stage 5. Oracle has stopped working on Solaris. They just said, we're done. Maybe we'll fix a couple bugs or whatever, but it's not really being developed anymore. And the other ones are they're kind of limping along, but again, mostly for pre-installed sites that don't want to change. But it's very hard to imagine. So again, you have an entrenched industry in the 90s who basically is not here anymore, which I think is quite surprising. That's also true in the database space. When I was in the 90s, the big databases were, Oracle, Sybase, Informix. I used Ingress and Informix as well a lot. Oracle's still around, although again, it's hard to, again, same question, I'm gonna make a startup and I'm gonna standardize on Oracle technology. Like, really? I guess, but it's kind of a funny thing to say. And I speak to a lot of Oracle organizations, Oracle DBAs, and I'm like, would you start, if you were creating a startup today, would you standardize on Oracle? And they're like, a lot of it is getting people to change their mindsets because they're just used to saying Oracle was always the thing I wanted. Well, okay, maybe Solaris was always the thing you wanted, but it isn't now, so why would Oracle always be the thing you want, right? DB2, it's not at stage 5, it's probably somewhere in the stage 4 area. MSSQL, they're kind of got their niche, a lot of data warehousing activity there. Certainly departmental servers that want something that's integrated, a lot of tooling around it. So they're kind of going in that ease of use area. Sybase, I think it's end of life. I don't think it's being developed still. Maybe it is. I don't hear about it much. Same thing with Informix and Ingress. They made sort of a run at open source for a little while with Computer Associates, and then there was another company, Active, it's just a couple years, and yeah, they had a whole thing. CA is where software goes to die, that kind of thing. So it's kind of interesting, but again, when 20 years ago, 25 years ago, these were the kings. So the database industry is definitely changing. Postgres, because of that variety of way we do development, it's improving in multiple dimensions at the same time. So you have ease of deployment improving, you have enterprise improving, and then you also have new platform improvements and workload improvements. So it's not improving in one direction, it's improving in multiple directions all at the same time. And if you look at a major release, you'll see improvements in all these directions. So when does software die, right? Well, if it's proprietary software, it dies when the owner can no longer make a profit from it, right? That's the sad ending of a lot of the software that we used to use. And unfortunately, it declines long before its death because of profit maximization. So that sort of limping along, kind of software that we're kind of used to. It's sad, but it makes it makes an economic sense, right? But it's not a great place to be for customers. Open source can't die in the same way because, again, nobody controls it. It's sort of this thing that just kind of keeps going. Open source remains active while it serves a purpose. So as long, it can always be resurrected. Again, as I said, in 1996, Postgres was in a way resurrected to be an internet-developed database. So in a way, software is ideas. It's not a physical thing. And ideas don't die as long as they're shared. And ideas are shared as long as they're useful. So I would say Postgres will live as long as it's useful. Just to give you a crazy example, my daughter's majoring in philosophy, and, she studies Plato, right? And when I was in college, I studied Plato. And Plato goes back to, I don't know, something BC, 600, 900, 1200 BC, something like that. I can't remember how long it goes back. We're still talking about it, right? The guy wrote it several millennia ago, and we still talk about Plato. Why? Because his ideas are still relevant today. His ideas still have an application and a use, and that's why we study it. And the same thing of pretty much anything, any idea. The Iliad is still read. That's got to be from 1200 or 900 BC. So, does anybody have a date on that one?
The poem, the Iliad?
Yeah.
Homer's Iliad?
Yeah. Yeah, it goes way back. But it was probably the first novel, epic novel that was written and still is studied today because it still has, they still do movie adaptations of it. I saw one a couple weeks ago. Yeah, it was like a spoof of it, but it was pretty funny. But anyway, yeah, so that, in a way, when I talk about living forever, that's what I'm saying. As long as it has a use, it still gets used. Let's be more practical. Let's talk about a survey that was done by Black Duck Software. Now, unfortunately, this is 5 years old, but the conclusions are pretty much the same. They're basically in 2016 reflecting back 10 years and saying 10 years ago, so we're not talking 2006, hardly anyone would have predicted that open source would be used and be ubiquitous worldwide just a decade later. And there's a bunch of quotes in here, but basically it goes to talk about how it's, basically for Internet of Things, for mobile, for servers, pretty much all across the board. And this slide, I think, is the most interesting. Mark Linster did reference this again this morning. I didn't pay him to do that. He just did it on its own. But the point here is that what they did in the survey is they talked to people who had been using open source for 2 years. And they asked them, why did you choose open source 2 years ago, right? And then what value do you have? Why are you continuing to use open source? So why did you choose it at first? And now why are you continuing to use it? And the interesting part is their choice 2 years ago is different than the reason they're using it now, okay? So the number one reason that they're using it 2 years ago, they said, was cost, okay? So, this is my classic $5 supermarket chicken, right? So the $5 supermarket chicken gets them into the store, gets them using the software, usually in a small way, but is a way of sort of testing, hey, I can save some money, I can use this Postgres thing, I don't need to buy an expensive, fancy database for this particular application. But then you roll forward, and all of a sudden, instead of being in this niche application 2 years later, that database is all over the place. It's not to save money anymore. Number one reason that they stay with open source is innovation and competitive features, right? Because you don't have the kind of profit maximization, no innovation stages with open source, okay? It doesn't have that sort of pathological life cycle. Freedom from vendor lock-in, quality of solutions, ability to customize and fix, all higher than saving money. Saving money gets them in, but as Mark said, you don't get people to go to conferences, you don't get hundreds of blog entries a year, you don't get huge, big corporations involved just to save money. That's the money they're saving based on their full cost is tiny, right? NTT, I guess, isn't probably excited about saving a huge amount of licensing. What they're excited about is innovation. Same thing with Fujitsu, same thing with all the cloud vendors, okay? The innovation is what they want. The cost is a benefit, but that's not really, I think, the major driver. Again, operating systems, cloud, big data, Internet of Things, all areas where open source dominates. Databases, even 5 years ago, were a huge area, and they've gotten huger. in terms of how much open source is dominating these areas. New databases coming all the time, some based on Postgres, some not, but a hugely active area. This slide I really kind of love. One of the things, having been in the industries for so long, is trying to understand, if you're entering an organization, how do you promote Postgres to decision makers? Okay, and I have a blog entry about this as well. Most people start and think, I have to convince the managers to use Postgres. So I'm going to talk about cost savings. I'm going to talk about no lock-in, and I'm going to talk about less expensive development. But in many cases, the people who are going to drive Postgres into those organizations are not the managers. Because as I said before, cost saving compared to the migration cost, it may not even make any sense for that manager, right? But what would make sense? The ability for developers to have innovation and to speed their development. The ability for administrators to have higher quality database software and to make it customizable and better interoperable and more options. Okay, so when you're talking to an organization about bringing open source in or a database, you should be thinking, who am I talking to? Am I talking to the people who worry about the money? Am I talking to the people who do the development, or people who are talking to management? Depending on who you're talking to, you talk about the value in a different way. So Postgres innovation, let's give some examples of this. And actually this gentleman in the blue, I believe, is at the conference today. So just throwing that out there. This is Joe Selko. This is actually a picture from, help me here, is this Prague or Tallinn? I can't remember. Anyway, you can go down to the picture down there to see. Anyway, Joe Selko, big SQL author, and he's obviously been excited about Postgres for many years, lives down in Austin. I talked about E.F. Codd as sort of the originator of relational systems in 1970. We're still kind of going with his ideas 51 years later. It's kind of surprising. Michael Stonebreaker, I talked about him. He basically started Postgres in 1986. And one of the key things that he did was to talk about extendability. He was going to create the next generation of relational system. And that means extendable data types, extendable indexing, extendable server-side languages. Okay? And this is the result. This is the system tables for Postgres, and it includes a system table for functions, a system table for languages, a system table for indexing methods, a system table for aggregates, a system table for operators, a system table for data types. And because of that extendability, Postgres is able to become a multimodal database that can meet today's data needs much easier than other more rigid relational systems. That flexibility allows Postgres to always stay fresh. For example, if you need a data type that handles UPC symbols or book numbers, we have an extension. You load the extension here in red, and all of a sudden you have 8 new data types. Maybe you need a server-side language that has some special capability like PLR. PLR is really good for analytics. Maybe you need a JavaScript server-side language. Maybe you need a Java one or a Perl one or a Python one. Maybe you're doing AI and you want a Python server-side language. Again, that capability is tremendously useful. And again, if you're curious, a lot of these slides have URLs there at the bottom in blue. And if you click on those, you'll be taken to one of my presentations or another resource. We have a lot of complicated index types. Tomorrow, I'll be giving a talk about indexing in Postgres. So if you're curious about how these indexing types work and why they're useful for non-relational data, make sure you come to my talk tomorrow morning. And the reason it's important is because B-tree is good, but B-tree is only good for certain types of data. And if you're doing something like JSON or full text search or GIS, you need other indexing types. And because Postgres was designed to be extendable, it's designed with these additional indexing types. And again, makes Postgres very easy to move into new data needs. Full text search, Oleg Bartunov is here today. He was sort of one of the authors with Theodore Sigaev, who brought full text search into Postgres. And again, because of the extendability of Postgres, it was very easy to add. Here's an example of a full text query in Postgres. I do have a talk about non-relational Postgres. If you're curious about that, again, on my website called Non-Relational Postgres, and it goes through many of the non-relational data types that make Postgres unique for today's workloads. NoSQL, again, Postgres has a lot of capabilities that allow you to do NoSQL-like workloads with Postgres. Here's an example of a JSON query using a special operator. The @ sign, here I'm going to use my pointer here we go. The @ greater than symbol that we add to Postgres to do JSON queries. And again, we have specialized indexing types to help with that. Range types, Jonathan Katz is here. He was one of the sort of key people who got excited about range types. I remember a talk he did in Chicago, the first time I really understood what range types were for. So if you're curious about that, find Jonathan Katz and ask him. He'll love to tell you about it. It is great because it combines a start and a stop in a single field that can be easily indexed. The short answer. Here's an example of a range type, saying give me a car that has a start and stop in this period, using an index. Geometric types, we have lines, points, circles, polygons. There's a query that does darts on a dartboard, but we also have GIS data types, which handle geographic information system data very efficiently. And here's a query that uses that. Foreign data wrappers, if you want to access other data outside of Postgres, we have over 100 of those where you can basically go and access Oracle, access Mongo, access Hadoop, access Twitter or S3 buckets or whatever your data is. We probably have a data type that allows you to get there. And again, this is an illustration of that. Data analytics, if you're familiar, if you want to do data analytics in Postgres, there are a lot of people who are working in this area. We've made a lot of progress with common table expressions, just-in-time compilation, grouping sets, Brin indexes, all in the past 5 or 10 years. Window functions, super powerful for data analytics. And we've made improvements in sharding, fortunately in Postgres 14 that was released 2 months ago. And I'm still waiting to get the results of how well we did with that. But I think that's an area that we're going to be moving into in the coming years and a big need for us. And again, this is how sort of sharding works. Here's a presentation I have about sharding if you want more detail about that. I'll be actually giving my sharding talk for a China and Asia conference in 2 weeks. But there's videos also of that you can watch, so feel free to take a look at that. We still have a couple years to go, but we're making progress, and I'm pretty happy about it. And this is
The extensive use of SDW on sharding?
yes. It uses foreign data wrappers, parallelism, and partitioning. Yeah. Mm-hmm. So I've been at this for 4 years. I'm going to stay at it until we get it. So. So the question is, how would we handle HStore, JSON, large data? I don't know yet. I'm not sure I'm ready to understand exactly. I think we're still in the prototype stage, I would say. So the question was about large, long data types with JSON, with sharding, and I think we still need some research on that. I'm looking for people to actually start benchmarking Postgres 14 to give me an idea of where we are. Where are the bottlenecks? I think we're still in that exploratory stage. I understand there's network, yeah, he's saying there's network potential issues with moving data around a lot, and that might be an issue we don't know yet. And let me just close out talking about the community structure, which fortunately is very healthy. Again, if you're curious more about that, my future Postgres challenges gets a little bit more into the community structure. But as I mentioned before, we're BSD licensed so that it's available forever. We are diversified culturally and geographically, and obviously multi-company. We have a strong history, 35 years of regular development, 25 years of major releases, about 180 features. Postgres 14 had 220, so we did a lot better during COVID, funnily, than normally. And as Mark Linster also mentioned, we are one of the most loved databases. If you're curious what's going on, there's a PG Life website, kind of shows you everything that's going on at this moment. That's how I keep in contact with what's going on. So I want to thank you very much. Unfortunately, I don't have any time for questions, but I'll be here to answer your questions if you want to come on up. I think you're going to have a great rest of the conference. I'm excited to be back in person. I'm sure you are too. So thanks very much.